Hi, my name is Jeffrey Barrows. I am with Sentai, and I'm here to present to you a proposed solution to the AFWERX Microelectronics Challenge. Now, most people know me for my work in providing vision-based navigation to nanodrones, for example, this Crazy Fly. And you can see here one sensor weighs about a gram. 4 of these sensors is enough to let this Crazy Fly, let this nano quadrotor hover in place, fly around, avoid obstacles, fly through tunnels, even navigate and determine paths around obstacles, all using onboard vision, no motion capture system or anything like that whatsoever. And again, this is in daylight or in low light levels as well as in pure darkness. Now, the heart of this technology is actually the sensor right here. This is what we call a sensor. And if you look really closely, you see 2 vision chips, 2 camera chips with custom optics. I personally developed the vision chips using a 0.6 micron process. That's really quite archaic if you think about it, but the performance is great. And an ARM processor on the back, and this weighs about a gram. This computes optical flow, stereo vision, and pulse light to basically obtain some sort of proximity type of sensing. And again, 4 of these is enough to provide an interesting level of autonomy to a nano quadrotor. But you know what? I would like to get smaller. My proposed solution is to take the ARM core and just one of the vision chips and squeeze it into a single monolithic package. We would still have an off-the-chip optics that would focus light onto the vision chip, but I believe that the whole camera could be made to weigh on the order of 10 milligrams, maybe 20 milligrams, maybe 5 milligrams. It depends upon the optics that particular application would want. I see this as having 3 interesting sets of applications. The first application, of course, is, again, providing vision for a drone like this or a smaller version of a drone like this. If the sensors weigh less, then we can have then the platform itself doesn't have to carry as much weight around, and it can have a longer endurance. Or we can stick it on yet a smaller drone. A second application is something people wouldn't think about, but we could provide peripheral sensing to various types of general robotics for larger robotics. Can you imagine a robot that had an eye in its hand or in its fingertips? And as that robot is trying to manipulate objects in the environment, it would have close-up perspectives or views of what it is trying to manipulate and increase its ability to do so. Or you can imagine these types of sensors in the leg or the foot of a robot, say a walking robot, and use that as a way to help navigate through an environment. And because a sensor that weighs 10 or 20 milligrams would be practically nothing in terms of additional weight or power draw that would provide to the robot, so it makes perfect sense to do that. The third application is interesting as well. Why not take these sensors and populate them around an environment and use this to make eyes for the IoT? Here's one thing. I propose within the vision chip fabric to make it a flexible acuity, flexible resolution, so we could operate the chip in a hibernation mode, where it is grabbing imagery at a very low frame rate, at a low resolution, with the ARM core running at a low rate, and it could run for perhaps a year on a single battery. And then when it sees something of interest, it can wake up, grab the field of view, grab an image at a high resolution, process it, perhaps send some information over a radio link to whatever is interested in it, whatever needs to use it. So, 3 applications. Please check out my architecture in the solution description. And for those of you that are coming across this video from outside of the AFWERX Microelectronics Challenge, please check it out. Look at the link below and check out the AFWERX Microelectronics Challenge. It's very interesting. Thank you.